We're Group 11. We had engine number 15. I'm Kyle Estes.
I'm McKenna Patterson.
I'm Karima Brown.
And I'm Caitlin Kovach.
I did the camshaft and the small gear. These are a few views, as you can see, from the top view, the side view, and an angled view. The first thing I did is I started off with the gear model. I used the toolbox to use the gear setting for spur gear, and using the dimensions from the gear I modeled that. I then added the spokes and the center ring alignment. Then I used extruded cuts and entities to add in timing marks, extra pieces, and alignment pieces. I then added the proper fillets to angle certain edges and smooth them out. The next part was the metal clip. I first started off by modeling one side of the clip, and then I mirrored that entity across a plane, and then I used a semi-ring on the bottom to connect the two. I then added the stopping mechanisms on each side of the bottom of the ring, also an extruded cut through the center for the pin that goes through it, and I also added fillets at the end to smoothen out some areas. The next part was the camshaft sheath. This is actually connected to the gear, but I thought it would be easier to model if I separated it into two pieces. I started off on one end with a Boss extrude cylinder, and then I modeled the cam of it, which you can see is added on to the end of that cylinder. I then added the middle section, which is similar to a cylinder, but it actually has two flat edges on each side. I then mirrored the cam across that body and switched the angle at which it was connected. And then I added the connecting cylinder that goes from the gear to the camshaft sheath and made a hole through it in which the rod will be inserted. I then had the metal rod and metal pin. The metal pin is the piece that goes through this hole in the metal rod and is what attaches the metal clip to the metal rod, and the metal pin is the piece that connects the metal clip into the rod.
So I modeled the gudgeon pin and piston, and here's a picture of them assembled together. So for the gudgeon pin, I sketched two concentric circles, and I extruded this sketch to the full length of the pin. After I extruded it, I chamfered the outer edge of the circle and I filleted the inner edge. For the piston, I revolved a sketch to create the body and the rings of the piston. And then I created the circular cutout that goes through the entire piston, and I created the three cuts on the front face. After that, I shelled out the bottom of the piston and made sure that it was appropriate depth and thickness. And then I added Boss extrudes inside. I added this Boss extrude here, and then I mirrored it, and then I added the two Boss extrudes on the bottom. After that, I filleted the necessary edges in the bottom, which included both of these Boss extrudes, the extrudes on the bottom. There were also fillets on the bottom face of the piston and on the walls. And then I added this X, which tells you where the pin goes in the piston. And I also did these rectangular cutouts here. For the front face of the piston, I had a couple cuts I had to make. There was one that was at the bottom, which went through the entire piston. And then I did this rectangular cut above here, and I cut through this first ring. And finally, I revolved this sphere here on the front. Then I extruded two rectangles on the side to make the side tabs, and I also created some more fillets, which included fillets on all the cutouts, the fillets on the side tabs, and the fillet on this first ring. Then I mirrored all these features to the back, and I also chamfered the circle on the back. Then I filleted the top of the piston and added the timing mark on the piston. And here are some more pictures. There's a side view and a front isometric view, and then two bottom views.
Okay, I did the connecting rod for our engine. And to start out, I did the top piece first. To do the top piece, I went ahead and I created 2 half circles, and I extruded them both to the appropriate lengths. After that, I chamfered both of the sides of the inner half circle to create the appropriate image of the top piece of the connecting rod. Once I chamfered both of the sides of the inner circle, I went ahead and sketched and extruded the cylinders on the sides of the top piece of the connecting rod. After that, I extruded the rectangle on the shortest side of the cylinder. And once I extruded the shortest side of the cylinder, I went ahead and made the cutouts for this part of the connecting rod, as well as making the holes for the 2 screws. To finish the top piece of the connecting rod, I went ahead and created a rectangular cutout on the back side of the connecting rod, which can be seen here. I also created a final cut extrudes for the front and the back sides of the top piece, as well as the final cut above the bottom end of the connecting rod top piece. And then we also added a identifier for our prototype. For the bottom piece of our connecting rod, I went ahead and made the body of the connecting rod first by following the top piece, because they're very similar. So first I extruded the body of the bottom piece, and then I chamfered the inner circle like I did on the top piece. The next step that I did was create the cylindrical sides of the bottom piece of the connecting rod. Once I created the 2 body extrusions, I went ahead and created the cut extrusions on the front side and the back face. After that, I went ahead and created the 2 holes for the screws of the connecting rod. Once I created the 2 holes for the screws of the connecting rod, I went ahead and made the handle for the bottom piece of the connecting rod by extruding the sketch for the handle. Once I created the handle for the connecting rod, I went ahead and cut extruded the inner face of the connecting rod, as well as the hole for the gudgeon pin, as well as the sides of the body of the connecting rod. Once I created those cutouts, I went ahead and created the angle extrusion that's on the inside of the handle, that's in between the body and the handle of the connecting rod. And once I created the angled extrusion, I went ahead and created all of the fillets at their necessary measurements and cosmetic threads. And here you can see the different views of the connecting rod, the left, right, front, and back view. And here is the top and bottom view of the connecting rod.
Okay, so I modeled the crankshaft for our engine. And to start off, I created basically 3 sections for the initial shaft. You have the longer section with the larger diameter, and then a lofted piece, and then a smaller section with a smaller diameter. And then next I created connecting cylinders that will eventually connect to the weighted portions. And then I made the weighted portions for the counterweights, but I left them as full cylinders to begin with. So then I cut out the middle section between the 2 counterweights so that eventually I could add the connecting rod. And then I cut out the shape of the actual counterweight to create the angled surfaces on the side. So then I had to create this sort of connecting piece right here. And to do that, I just extruded a basic rectangle to begin with, and then later on I'll add fillets. And I also created the angled surface at the top of the counterweights. And then basically everything I did to that one side, I had to do on the other side. So that's what you see here and here. And then I also created the actual surface that would be connected by the shaft that the connecting rod goes onto, which you can see here. And then there's holes on either side. So one of the sides is just a basic cylinder of all the same diameter, and then the other side had one that chamfered down into a smaller cylinder. So I created those. You can see one here, and then the other one here. And then on This one, I added the threads on either side. So one of them's external and then one of them's internal. And then I created the draft angles on the counterweights, and then eventually I'll create them up here too. And then I added a whole bunch of fillets, as you can see here and here. And then I also created this sort of like connecting portion and added a cutout. And then I added the draft angles here and all the other fillets. And then here's the additional views, the top view, bottom view, and side views.
So for our prototype, we all agreed to create equilateral triangle cutouts for our prototype of our connecting rod. And the justification for this was to create a truss structure that will retain the strength of the overall connecting rod while also decreasing the material used in the connecting rod.